Hi there. Today we're gonna talk about microwaves.
Microwave. It's microwave.
Today we're gonna talk about microwaves and microwave appliances and how they work.
First, we're going to talk about the anatomy of a microwave. A microwave is made up of several different components, most importantly, a magnetron. So that's what we're going to focus on. A magnetron is essentially the heart of a microwave. And the way it works is a cathode emits electrons inside of a vacuum tube that are attracted to a positively charged anode on the other side. A strong magnet is located beneath the anode and it generates a magnetic field along the tube. The electrons in the tube spin around and pass cavities that then create a resonation that is emitted in the form of a microwave. These microwaves are channeled through a waveguide and radiated into the compartment where the food is heated.
The way a microwave heats up your food is through a process known as dielectric heating. Dielectric heating works by causing molecular rotation of polar molecules, and in this case we're talking about water. As we know, water is a dipole, which means having a negatively charged side and a positively charged side. In the microwave, the magnetron emits an alternating, oscillating electromagnetic wave that the water molecules in the food try to align with. This is known as dipole radiation. As the field alternates, the molecules reverse direction. While this happens, the water molecules constantly push, pull, and collide with other molecules in your food, increasing the thermal energy. An example of dielectric heating can be seen when we put sugar in the microwave. Dry sugar with no water will not experience any heating, but if sugar is diluted with water, the mixture will begin to boil. Microwave radiation falls on the electromagnetic spectrum between radio waves and infrared waves. So regular just microwave radiation has a wavelength that spans between 1 meter to 1 millimeter. And for the frequency, it goes from 300 megahertz, which is 100 centimeters, to 300 gigahertz, which is 0.1 centimeters. But for your household microwave oven, the wavelength is usually around 12.2 centimeters, with a frequency that is 2.45 gigahertz, which in centimeters is 12 centimeters.
A lot of crazies out there are worried about the dangers of radiation, but the radiation that you need to worry about is ionizing radiation, which is any type of electromagnetic wave or particle that carries enough energy to remove electrons from atoms. And microwave radiation is non-ionizing. So if you're anything like me and you like to watch your food cook, you can go ahead and do it without any worries at all.
Quick disclaimer, microwave shielding isn't perfect and some microwaves may leak out. While it won't give you radiation poisoning, continuous exposure in close proximity may cause lasting damage to your eyeballs. With that said, now we're going to show you some footage of various materials that we put in a microwave. To those unfamiliar with the expanding properties of some foods and materials in the microwave, two commonly referenced examples are marshmallows and bars of soap. How soap and marshmallows behave when microwaved is a great demonstration of the water agitating effects of microwaves. The reason that bars of soap and marshmallows expand in the microwave is because they're both full of tiny little air pockets. When the microwaves heat up the material, it's heating up the water in those air pockets. The water vaporizes and it causes the air inside the pockets to expand. As you can see, while microwaving the soap changed its shape dramatically, the change was mostly cosmetic. Further testing revealed to us that it still functioned perfectly as regular soap.
So now we're just gonna put everything that we've ever wanted to put into a microwave, and we're gonna learn about arcing. Just throw some Pop-Tarts, make sure the foil's on there, a couple of cans of Red Bull. You got any tools? You just give those, wherever they'll fit, really. Just gotta.
With our first trial, we didn't quite get the result we were looking for, but then we removed the Red Bull and some of the Pop-Tarts and we got a much greater effect just using tin foil in the wrench. Now it's time to explain microwave arcing. As we now know, a microwave creates an electromagnetic field that propagates around the chamber. When this field comes into contact with metal objects, the field pushes around free electrons in the metal. These electrons accumulate at the sharp edges of the metal, where they are prone to discharge into the air. The air around the edges ionizes as the electrons enter it, and the current then travels through the air as sparks. In conclusion, the microwave is quite a nifty invention. It allows us to enjoy some of our favorite snacks without having to wait for it to be cooked, and also it can provide some entertainment value as well.
Oh! Oh boy! Oh, that is so bad. Oh.
Uh-oh.
Okay, turn it off.
Uh-oh.
Turn it off.
Uh-oh.
Couldn't find the button.